Previously on The Bald Engineer.
Oh God, wait a minute, what?
Ooh, you're dirty.
Oh no.
James, you're looking at the wrong chip.
Oh my God.
Excuse me. Farts.
And F stands for fun.
Pick.
Yep, fell right for that one.
Tab is correct.
Oh no, 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 no. New work. Oh my God, are you kidding me?
And
Why is it triggering now? That could have gone a little better.
I can't hear anything. Turn it up. Hey there. Welcome to the stream. I'm James. And you're you. Happy Thursday, everybody. All right. I I had a little bit of an accident right before stream. I forgot to make the stream viewable. Whoops. So just cleaning up a few things, and then I will be more ready to go. How's everybody doing? So we're going to continue and hopefully finish the Apple IIe power supply. I think we only have one major section to do, and then I'd like to get that section done, and then I would like to see where we're at with ERC. Although I feel like we ran ERC already, and it wasn't terrible. I don't know. All right, I want my, where is my, where's it at? Where did it go? Where did who go? Waiting for web server. Well, shoot. Okay. All right, so I won't have my keypad tonight. I don't know what's wrong. Okay. No worries. We'll continue anyway. All right, so here is where we are at. I can't press the button. Oh, wait. What if I just plug it in? I wonder if it'll pick it up. I don't think it will. Nope. Okay. Hey, Francois. Welcome back. Happy very late evening for you. Or very early morning for you is actually probably... Let's see. I'll give this one more shot. Maybe it was mad because it wasn't plugged in? No? Launch. It's not launching. Oh well. Okay. So here... Oh, no, that's not what I wanted. Well, I guess I need that because I need to do this. Okay. Oh, nice. You know, one project I don't even want to say it out loud because somebody's going to steal it, but one project I have in mind is to look closer at the Super Nintendo or Super Famicom chipset and determine if its graphics controller has a backward compatibility mode built into it. Because very early on, the Super Famicom was supposed to have backward compatibility with the NES or Famicom. And I wonder if the Silicon has support for it. I think there's a good chance that it does not, because Nintendo didn't do backward compatibility. But I sort of wonder, what if they did? And that'd be kind of cool to figure out how to make that work. Okay. So I think we're around here somewhere, right? Because, I just messed up my mouse. Nope. There. Nope. That's way too sensitive. That's like 10,000 DPI. That's like no DPI. That's not it. Must be this one. Yeah, it's this one. All right. Yeah, so, hey, Nicholas. So we'll be working in Schematic, so we won't be seeing too much on DRC, but we will be looking at ERC today. I find DRC tends to be a little more straightforward. It's like there's to me anyway, once you understand what most of the rules are, it's a little bit easier to say, okay, it's a little bit easier to work through. ERC, I think, still creates a lot of just weird, like, what do you mean this is a problem kind of situations. So, all right. 2S8621R. No. All right, what is this transistor? I'd like to know what the pin out of this transistor is so I can pick the right symbol. And I'm actually assuming this is one of the switch transistors for the supply design. See, I think that's Oh, that's a B. So maybe it's 2SB621R. Yeah, that sounds more like a transistor. All right, let's see what this looks like. So this goes ECB. So we're going to look for a Q, P and P, emitter ECB. There we go. And then we're going to rotate. Rotate with R, and it's done. That's nice. All right, so this is going to be, let's edit this because we're going to do a Q3, and this will be a 2SB621R. And I'm actually going to change the symbol. Oh, that's not what I want to do. I'm going to change the symbol. Nope, that's not. I'm going to do change symbol, and I want to change it to, I think I made some that don't have pin numbers, just so it looks more like the schematic. So we'll change that. I forgot about that. I just thought of it while I was talking. All right, let's bring this up to here. Back on DRC and ERC, that's actually one of the next add-ons videos that I'm working on, is going to be related to addressing ERC and DRC errors. And originally I was thinking I was going to do ERC first, just because you start with schematic. But I think, oh, that is not how that works at all. Man, this is still, that's better. I think something is messing up something's changing my mouse settings. Okay, I did this completely wrong. This is supposed to come down like so. This is supposed to come over such that it looks like this. Like in schematic, the most popular one is power output is not driven by. Okay, there is something wrong with my mouse settings. It is driving me insane. It keeps changing. I don't care if there's an update. Oh, that's what's wrong. Oh, Windows. Okay, that's what the problem was. My mouse driver crashed. Okay, back to our regularly scheduled program. All right, so that comes down here, and then we're going to need a resistor here. Anyway, so power output pin was not driven by a power input, or power input was not driven by power output. That's probably the most common ERC error. And that's just because there's nothing in the schematic defined as a power output, it's a pretty easy fix. Like the easiest fix is you just add a power flag. But I think some people would like to know why you need it and how to avoid it in the first place. And then the other thing I want to cover, and this really, I'm not sure how to do this without coming off as condescending, but people need to understand that a warning and an error are two different things. Because I see a lot of people post like on forums saying, I'm getting this DRC error, how do I fix it? And it's like silk screen is clipped by solder mask. And it's like, well, that's not an error. It's a warning. And it is, to me, it's pretty descriptive, but I can understand if you've never made a PCB, then maybe it's a little more cryptic, but it is a warning. And then the other thing to remember, especially ERC, when you make a PCB, nobody cares if you passed ERC or DRC. So if the error you are getting is strange, well, you have the option to ignore it. I don't like how this is drawn at all. So I'm going to do it this way. I'm going to make a quick note on this one. Someday when I finally look at a power supply, the reference schematic we're using to redraw the Apple IIe schematic, or Apple IIe power supply schematic, is out of a Sam's book. And Sam's was a series of books that were basically like repair manuals for computers back in the Stone Age. And it looks to me like they did they reverse engineered one model of power supply from a single 2E, which is why I'm naming this schematic unknown, because I don't know which supply it is. Typically, Apple had 2, sometimes 3 vendors that they bought power supply units from. And like in this case, I don't know which one this is. And I would assume that there are minor differences. Even if Apple provided they probably just provided the specs of what they wanted, and then the supply manufacturer produced something that met those specs. So yeah, like Aztec, ASTEC is a really common one that they used for a very long time. All right, so we got I forgot to change this to R20. So I saw this really weird comment today from somebody who said their workflow is to draw schematics in Eagle, export them, and then draw the PCB in KiCad. And I can't for the life of me figure out why somebody would go through that kind of torture. Like that just seems like you are straight up asking for errors to be introduced in that process, and you're putting a lot of extra effort that isn't necessary. Especially that with the way that the KiCad importer works, with the way that it works. I mean, it's okay. It does a decent job of importing Eagle files, but it does a handful of strange things. And I guess if you do it long enough or enough times, you might get used to that. But it just seems like such a... I don't understand... especially the reason I don't understand is to me, the schematic editor in KiCad is significantly better than Eagle. I guess the only reason I could see somebody preferring Eagle is because it does have the scripting language built in. And KiCad still doesn't really have anything for schematic yet. Like I think 8 is going to have some framework in place, but it won't be until as early as 9 that there's a proper remote what is it called? RPC, remote procedure interface. Can't remember the name, but I heard John Evans talking about it. Man, it must have been at KiCad this year. I watched the online version. I'm really starting to think that these X's are meant to mean do not populate. But I'm still going to keep doing it my way. All right, we should probably label these. So this is R23 2700 2 percentages. Okay. Over here is an R32 150K. All right. And then over here, we're going to put a capacitor. But then we need another 2700K and another one of these. All right. And then let's grab a cap. We'll put it right here. This looks like about what we're doing. We'll call that C18. We'll call that 220 nanofarads. Actually worked for the guy that was named very well. I won't say his name in case he ever listens. Never mind. Never mind. The value got turned off. That's not good. Let's move this over here, rotate that, move this up to here, move this over to here, move that over to here. Okay, so this one goes here, and this one goes to here. He goes over to here. Oh, no. That comes up to here. Oh, missed that one. That goes to there. And then that goes to there. Nice. No, let's move this one over. That is much better. All right, so then we got to do a little more work here. So this one, we need to change the value and the des. This one, we just need to change the designator. We need to add a couple of these fancy X's. Uh, 23, 150K, 27%. 422. C17 is a 22 nanofarad. Farad. Put that to here and this up to here. All right. 120 R21 and 12K. R20 56 and R19 56. Nice. All right. You know what's funny is last week I was like, when we got to the end of the stream, I was like, well, we still have this whole block over here to do, and I was really not feeling it. And it turned out it took like no time at all. Should have just did it. Oh well. Okay. So we're gonna put a diode here. Let's see where this one goes. One in 4606 and 11. Okay. And then let's bring this one roughly down here, and that'll be diode 5, or as I like to say, diode. And then R15 connects on the other side of this diode. Oh, ads are running. That's what that was. Sorry. Sorry to those that are not running an ad blocker, even though you can't hear me. And that's another one of these mysterious 5-volt node. Let's just do that. That looks much better. Mucho bettero. Okay. Oh, hey, look what came back. Let's see if this is working. We'll try confetti. Ah, how about that? 22 millifarad? Did I miss? Ooh. Well, I think this is nanofarads because for a couple of reasons. One is it's so I'm assuming we mean C17. Let me move this up here. This is 22, so it's 10%, so it's not an electrolytic. This is drawn as a polarized or a non-polar cap, so it's probably a film. Same with this one. It's drawn as a non-polar, and it's 100 volts. So I think it's more likely that these are nanofarads. They're probably film caps, and they're shown in... Yeah. I'm thinking it. I think these are. I think they're film caps. The other reason I think that is this is a. I think we've determined that this is probably a reference of some type. I think it was Christian figured this out based on another chip of a similar. Based on another chip or idea. And so, yeah, so I think these are precision, because these are precision resistors. And so I think this is, yeah. So, yeah, I think, yeah. So, yeah, C18 is 220. And C17 is 22. So 220 nano, and then the other I think is 22 nano. However, 18 and C17 are film analytics. I'll do that. I have assumed film or ceramic. It's just I don't think C0G would have been available in that large of capacitance, so I'll bet those are some film caps. But yeah, so that's my assumption. Is just based on where I think it is in the circuit and what it's doing. I think those are going to be film. All right. Oh, you know what I didn't do? Yep, I forgot to turn that off. Whoops. You gotta so Onshape CAD has ads on YouTube. I mean, I guess that's not surprising, but interesting. I know for the longest time, like whenever I would watch my own channel, I would see the strangest ads. And it was just like, well, there is no point in worrying about monetization. Because, yeah, they just didn't have a lot to go on. However, fun fact, in the early days of ad-ohms, I used to run pre-roll ads on other channels to advertise my videos. Yep. I mean, those were the days where if I got 100 views, I was excited. So I would run an ad and get like another 10 views or something. Actually, ads would usually add, and I think YouTube did this. I don't know how they still do it because I haven't run a YouTube ad in forever. I actually think they kind of purposely made the values. Oh, that's not a ferrite. I think they purposely made your views go up when you ran an ad just so that you'd be more inclined to do it in the future. And it was never like massive. It'd be like 100. I would get 100 views for it. But these were back in the days before my videos would ever get 1,000 views. And so what I was more interested in was growing the sub number, which that definitely helped. Is that where yours at? I pay so little attention to YouTube metrics anymore. I have spreadsheets that track a lot of stuff, but all I'm tracking are the deltas from day to day. I'm not paying attention to like individual video numbers. I've kind of given up on understanding what works and what doesn't. And so I'm more concerned when I see a trend occur versus, well, pretty much versus anything else. All right, so 5 volt is over there. This. So we're gonna need another low value resistor. Pure tube? I don't know what that is. I'll have to look into that. Unless you're just making a comment. So I'm going to go with this one again. Let's disable that. Rotate this. And then we'll make this C11. You're C11. All right. Okay. And then up here, let's go ahead and edit this one, 12 and 68. And now we want the 270. All right, put that over to here. And then we'll come down to here. So if I edit this one, we'll add 1 watt, show that, and this will be number 13. Hey, Jake. Yeah, your face is C1. So, true story. I saw that comment in the corner of my eye, and I was like, "Oh man, is there a troll?" Which, you know, maybe you still are. Maybe you still are. Just kidding. All right. Okay, I'm done. Okay, C11, R1268, R13 is 270. So here's one, I don't know. So this is common in other CAD programs, but say you have these two labels, so in this case, there's the designator and the value on top of each other. If you left click and hold in either PCB or schematic, then a context dialog comes up to clarify your selection. And then that way, now I can hit M to move this one. So just something to keep in mind if you're having trouble selecting a particular element, click and hold. It's not, I mean, that's not like an innovation or anything. Other CAD programs do the same thing. But it is helpful that it is available. So then we got our transistor. Gonna add a texty text called reg because that's what they have in the original. And then that comes down to a 56 and I think to a 5 volt node over to a 56 through a 12K, a 10, a 470, 27, 150, 200, to 2700, 100K. Yeah, there's a troll. Oh, that must be what that wrench icon means. Okay, so then that connects to something over here, which is next to D8. Okay. All right, I'm going to move this over just a little bit. Oh, you know what we'll do? I'll just, let's move that over there. And then that way there's plenty of room. Okay. Okay, So if we just take a high level look at this, we come in from our off-board connectors to a filter cap, which is probably an X cap. Not well, it should be an X cap, but it's rated for 1K, which X caps aren't. Through a MOSFET, not a MOSFET, an MOV. Is there a selection filter in the schematic editor? Not yet. KiCad 8 will have a selection filter and properties panel. Wait, it'll have a properties panel. I don't know if it'll have a selection filter. Well, now I want to find out. Hold, please. I'm going to keep looking at this. Well, actually, I'm going to let something. Let me come back to that question. I'm going to load up my virtual machine that has KiCad Nightly on it. All right. So then we go through the MOV and the NTC into a choke. Okay. I'm going to move this over. And then we have our Y capacitors, which will be a 100 nano, 125 volt, and 400 volt, 22 or 2.2 nano. Okay, and then so those are connected, and then that goes to ground as it should. Well, it goes to the chassis. That's how I know those are Y capacitors, because they're going from line to Oh, I said that wrong. Yeah, no, that's the X cap. That's across the line. What? Huh. That's not how I would have expected to see that. Oh, I see what they did. Okay, I see what they did. So I don't think you can do that. Okay, I'm gonna move on because the Y caps aren't where I expect them to be. All right. So then we go into the rectifier. Oh, I never drew a box around it. Cool. All right, let's take a real super quick look at this. Would you? Yeah, sure. Look for. I thought I already told you to do that. So I don't see a selection filter, but this is nightly from about a week ago. What are you doing? And yeah, I don't see a selection filter. That's not the same thing. Yeah. But the thing is with okay. Yeah, so I don't think there is one, but there is a properties panel, which is going to help quite a bit. I don't think in Schematic the selection filter is as necessary as a PCB, because in the PCB you are building up layers, and so it's pretty common to have, say, like a ground plane, a mask negative, some silk screen, and maybe a trace, all in the exact same spot. And so the selection filter can really help with that. In Schematic, you rarely have things overlapping, and so it would be nice to have, I think, but I don't think it's near. It's not near. Well, it's not as necessary. There we go. So then we come out of here into our filter cap, which this looks drawn incorrect. This is incorrect. So this was supposed to come out and go into a cap. Okay, I don't know what I did here. So let's kind of redo this section over. So this is showing the inductor comes down. Move this out of our way. This is C5, right? So the inductor is down here. And then am I missing C4? Yep. So C4, which looks like a Y cap to me, except it shouldn't be on the rectifier, or I don't expect it to be on the rectifier, I should say. That goes to there. I'll use G to pull this down. Can the KiCad schematic be used to automate a PCB? No, not really. There's lots of advantages to this over the original schematic. The first one is it's far more readable. This isn't a great example because this one is actually in decent shape, but it's difficult to search and it's difficult to do anything with this. Once the schematic is in KiCad, you can do a Control F to search for things. You can highlight nets. You could export a BOM if you want it, things like that. So it's much easier to work with. The second part is it's going to exist for a very long time. Scans of some of these schematics are just atrocious. They're absolutely terrible. And so by having them redrawn, they're more likely to be preserved. Oh, that's why I was doing that. And so it's a matter of working with it. And then, I mean, I can tell you from my experience back when I was working on my Apple II project, having the schematics for the 2E and the 2C in KiCad made looking things up and working through how things are connected, it was just so much faster to look. I mean, there's so many tools available to search through the schematic that it's very useful versus a scan. And even with OCR, it's very hit or miss. So yeah. The point of the so this is part of what a project I call Bit Preserve, and the point of the project is to just preserve these old schematics. I think in terms of, will they ever replace the scanned PDFs? No, I don't think that makes sense. I mean, part of the problem is nobody's checking them, and so there are probably mistakes and errors in the KiCad schematic, but also there's errors in the PDFs. The problem with the PDFs is it's very difficult to fix those. So, yeah. Anyway, so the point of this is not to try to recreate a PCB. However, if somebody wanted to, this would be a really good starting point, I would think. So, I would be shocked if somebody hasn't already recreated the 2E motherboard or logic board. It seems like all of the vintage computers, somebody has reverse engineered their designs. Okay, that's looking good. And so, like in the case of what okay, and then just this is almost a tangent, but like in the case of these power supplies, What I didn't realize is there actually isn't a good schematic of the power supply, and it's because Apple didn't manufacture the power supply for their computer. They bought it from a power supply vendor. And so on one hand, it's the trouble is there's multiple supplies, so there's multiple designs, or vendors and designs. But on the other hand, this is like this to me is meant to be as a starting point that now we can go and reverse engineer an existing power supply and create a schematic that doesn't exist. And I think especially on power supplies, it'd be nice to have the schematics because it's so much easier to troubleshoot a power supply with. I mean, I hate trying to do anything with a power supply without a schematic. That's a nightmare. I mean, pretty much the first thing you do is redraw it on a piece of paper and try to figure out what the circuit is. Because it's pretty hard to just look at the PCB and be like, all right, I'm going to put my probe here and I should get 120 volts. It's just not that clear. Okay, so that is a correction. 47,250. All right. And then what is going on here? Oh, that's the other side of the transformer. Okay. All right, so let's follow this line up here. This will come over here. And actually on this one, you can actually see this divide right here. The PDF was broken into 2 pages, and then I stitched them back together in Photoshop. So that was very annoying. Yeah, I mean, I am all for the PCB side of stuff getting documented as well. However, that is not where my interest is at. That's not something that the power supplies, I'm more interested in reverse engineering just because I'm more interested in power supplies in terms of analog design. But like, because the PCB thing comes up quite a bit when people first learn about this project, and I'm not interested in recreating the PCBs for computers. It just that task does not interest me. Redoing the schematics, one of the reasons I like doing it is because it forces me to think about what's going on in the circuit, and that to me, there's an educational value to that. I think retracing a PCB is an interesting exercise, and there is a project that I want to do that on, but it's relatively small. Like, it's not a significant, I don't think it's going to be a significant undertaking. It's also Apple II that one's Apple II GS related. The memory expansion boards do not appear to be well documented. And because modern replacements are available, there's not much value to having those boards anymore. And so I think it'd be a fun exercise to tear some apart and reverse engineer them, because they're 4 layers. They're not just a 2-layer board. So I think that'll make it interesting. Okay, so this capacitor is upside down. So use Y to fix that. And I'm going to move the labels back. Try to keep the convention of the designator on top. We got D6 over here, and that's connected to 16 and 15, which then connects to 14. 13 goes to diode to ground, reverse biased, maybe. Over here is a shutdown transistor, PNP. 2BS6. Yeah, I thought that. Oh, I got that wrong. That's 2SB621R. Oh yeah, the test waveforms in this one, I'm not going to. So this schematic is one of the rare ones that aren't available directly from Apple. As I was saying, the power supplies weren't done by them. They just went to a vendor and said, we want these specs. And so this came out of a Sam's computer book, which was kind of like a repair guide for retro computers or computers back in this era. And so what they did is all of these boxes, like 36, 35, 34, and then the waveform pictures, I forgot what they call them. They've got a special name for them. There's like a table somewhere that tells you if you measure with a DMM and a scope, at this point, this is what you should measure. Same thing with like these voltages that are showing up here. They're just saying this is where you should measure something. You should measure 11 volts here, 11.4, which makes sense, right? There's the voltage or the diode drop. But I'm not transferring all of that information. I'm not interested in any of that. I would like to someday come up with like a wiki or something that somehow captures that information, but that's beyond what I want to worry about. Okay, so we need to make a, yeah, this symbol should actually be, we need to make a new symbol, because these are basically off-board connectors. So basically in the power supply, there'll be post where a wire plugs into it. And so I don't care about this other stuff, because like some of this other stuff is not even like these caps over here they're saying are part of the DIS2 interface board, which some 2Es don't even have. So I actually want to edit this symbol. And we're going to save this as con off board single. And I'm just going to delete this. All right. Okay. So then we're going to change symbol. And I don't know if this is going to work, but I want to say J14 star to con off board single. Holy cow, that worked.
And there was much rejoicing. Yay.
Yay. Okay. Except the symbol is going the wrong way. Yeah. So I'm going to do edit library symbol, and we're going to do this. All right. And then I'm going to right click and do update symbol. And I want to update all symbols with this identifier. Update close. That's what I want to see. Although that now looks like an antenna. Okay. Here's what I should have done. Should have done like this. All right, let's update that all in the schematic. It still has an antenna look to it, but that's probably closer to more correct. This, oh, okay, this did finally, I wanted to pin this. go. We don't need this. Delete that. Delete that. All right. Okay. Where was I? So we're looking at SCR1, and that goes to a 680 C20 J14.4. And this is J14.1 and J14.2, J14.3. All right. Up here we go from SCR to 18 ohm, R18 ohm, R18 100 ohms. Over here is to 22 ohms. We can actually clean this up a little bit if I just move this all down. So I'm using G to drag. So that's looking good. 22, R17, transistor, 2SB621, Q4 shut down. And then that was R26, 68, R27, Z1, A211. And then that goes J14 over to L5. And then down here we go C19, 1000U to ground. C14, 1000U to ground. All right, let's move this down. Let's move this over, and then let's rotate that just to give this all a little bit more room. There. All right, so C13, D8, D7, 1000, L6. Okay. Cool. So then I think, yeah, so then what this ends up being, wait. What is this saying? 5-volt source. Okay, I see what they did. This is actually, that's funny. They're saying block 6 is a 5-volt source. So this is actually supposed to be, this is our 5-volt node right here. And then we're going to add our power flag on this one. Because this is where the 5 volts comes from. Yep, I see that. Okay. And then what do we got up here? Up here was probably the 12-volt supply. Yep. So J14.4 is the positive 12-volt. Reverse engineering the repair schematic. Yeah. I wouldn't even say that we're reverse engineering because we're just copying it. Yeah. I mean, it's really just recreating it. To me, reverse engineering would be if we took the power, if we had this as a starting point, if we went to a real power supply and started looking at the components that it had, that would be reverse engineering. Or if we had that's minor distinction, but that's the one I would make. All right, and then this is 5 volts. I'm getting confused again. So J14.5, C21, R30, 20, L7, and then there's diode on that side. So this is the negative 12-volt supply. So we'll do add minus 12V. I'm not going to put a power flag this time, and for those that are more experienced, you know why. But there's a reason I'm skipping that. So let's bring this. Yeah, you could argue it's being scaled back from what this repair schematic has. I mean, until I have a better idea of which power supply design this is, I don't think it makes sense to take the time to recreate the notes. Like, I would almost want to fork that and make a separate version of the schematic with that information, because it may not apply to every design. Yeah, I fully expect that different vendors, power supply vendors, would have a different, at least a slightly different power supply design. That would be my expectation. All right, and then I looked through all this a minute ago. Okay, so I'm going to call that good for the moment. We can delete that. So what we want to do now is I'm going to save and commit this. So finished the recopy step. Now doing ERC. So we'll throw that in. And dun, 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 let's see what happens. Tools. Where's my ERC? Electrical rule check. We're not fully annotated. Okay. I'm actually going to run it anyway, because I want to see what's not annotated. Modified. Oh. Okay. Hold on. These are minor warnings. Notice that they're warnings. It's actually not a big deal. I want to change this symbol to NPN no numbers. And change this symbol NPN no numbers. Run that again. What's the other one? T1. Ooh, T1 got modified. Uh-oh. Let's do update symbol. I want to, okay, hold on. We're going to do edit with symbol editor. So this should be editing the one in the schematic. And then I'm going to do a save as into the 2E power supply library and overwrite the one that's there. So basically, KiCad is this electrical rule. The symbol has been modified from the library. It's a warning because it's just telling you that you've modified the library symbol in your schematic, so it's out of sync from the library. And this is one of those that, number one, recognize it's a warning, and number two, you have to decide if that's an issue for your design. You know, if you literally change the symbol, you probably want it to be different. KiCad keeps a copy of the symbol in its project so that it doesn't have to have access to the library. Okay. Let's see what our ERC says. Item not annotated. Okay. Well, that's an easy one to fix. So this is supposed to be IC1. IC1. And reg, we'll do this. Let me move this up here. All right. I'm going to save and we'll run it again. This isn't. Oh, this one's not annotated either. I thought I gave this an annotation. I'm just going to call it JP999 because it's not annotated in the original schematic. This is funny. I forgot to annotate this big transformer, even though I named the symbol T2, which is what it was in the schematic. Okay, so that one's easy to fix, or unannotated is easy to fix in this case because we're copying the annotations from the other schematic. If we were not, what you should actually do is make sure in preferences that the annotation options, so preferences, schematic editor, annotation options, you would actually want to enable automatically annotate symbols, because then KiCad would take care of that for you. And then if you were in a situation where you had stuff that wasn't annotated, under tools, there is a tool that will annotate things for you. So you should do that before you run ERC and before you move stuff to a schematic or to a PCB. So anyway, okay. So let's run this again. And now we're getting input pin is not driven, input pin is not driven, input power pin, input power pin, input power pin, input power pin. This is by far the most common ERC error. And if I zoom in, so what I'm going to do is I'm going to zoom in so that when I click on an error, we go to it. And so basically what KiCad is saying is this power flag symbol created a net called -12, which is a global power net. However, nothing connected to this net is a output or a power output. So nothing is actually driving the voltage. I think a misconception is that people think that this is flag is a identify, like it creates, well, all it does is it creates the net, or the rail, the 12 volt rail, -12 volt rail. But KiCad doesn't know whether, like, is this connector supposed to be what drives the bus or drives the rail, or is the rest of the circuit? And so to tell KiCad that this is actually where we expect the -12 volt rail to be created, we have to give it a power flag, because this tells KiCad, okay, this is, does this actually have a description? I just thought of that. Yeah, it's a special symbol to tell the ERC where power comes from. Okay, well, that said it better than I did. All right, and then we're going to do the same thing for the 12 volt or the -5 volt. And I'm just hiding the text because I don't really think it's necessary to have it. In fact, I'm going to move this one over to the other side, because this is actually the genesis of the power. I mean, we should really put this way over here, but it doesn't really matter. I just want to point out that I just want to make sure it's clear that this off-board connector is not, it's actually the output. And then we'll actually go ahead and just add this to, where are we at? There's a jumper somewhere over here. I'm just going to add it to this one. All right. So we'll save that, run this. Oh, come on. Now what are you mad about? Oh, I know why. Because, oh, what? No. So I'm going to edit this library symbol power input. Yeah, that should be fine. Okay. This one's bothering me. This shouldn't be a problem. This should be driven now that I flagged the other one. Was there a cap? Oh, because there's a cap between them. That's why. All right, so that should get rid of the one on ground. And then we're just going to put a flag on either side of this thing, because I still don't know what it is. I think it's a voltage reference. I don't know. Okay. Well, that was easy. Donna Noble. What? Yeah, that was like, I remember that Doctor Who episode. That was back when I was like waiting for them to come out and watch them as soon as possible. It's using free infinite energy. Yeah, absolutely. Hey, 48K or Josh, good to see you, man. Missed your streams the last couple of weeks. I've had to actually just get stuff done on Tuesdays instead of give you say mean things about Atari computers. I was trying to think of, instead of giving you a hard time. That's what I was trying to say. Okay. Well, we've given this a rough look. We've looked this a rough look over. I have we've passed ERC. There's a few things I want to look at after we finally get a hold of a real power supply, which I'm probably going to do offline and make a video about. In fact, I'm actually thinking about, if I have a supply that matches this schematic, I want to pull out the inductors and measure the inductors to find out what they actually are, what their values actually are. So, okay. So we're going to call this one, oh, no, not done yet. I got to do one more thing. File, let's open this up. I've shown this before, but I'm going to show it again. So so one thing I've been trying to do in BitPreserve is create PDFs of the schematics. And so one thing to know with KiCad, when you create when you want to create a PDF, even if you have a PDF printer installed, you should use file plot instead. And the reason, I'll show you in just a minute, is it creates a vector version of the PDF. It creates a vector version of the schematic that Acrobat is mad about for some reason. What are you doing? All right. And so for example, oh gosh, where are all of my, where's the, where is the text? Can I just do I have to do edit? How about comment? I'm missing the text selection tool. What? Because these are add text. Whatever. What are you recognizing? No, stop. Everything in here. Wait. Something's wrong. Something is wrong. Everything in here should already be text. So what are you performing? What are you doing? Why does it keep locking up? What are we at? L4 and R14. Ooh, look at that. Oh, that was a mistake. Wire loop there. Let me see. Oh. Okay. Yeah, thanks for catching that. Yeah, I think I drew them together, and then that was just a mistake on my part. I know what I did. I was just being dumb. Thanks for catching that. Electrically, it doesn't really change anything, but it is kind of sloppy. So, okay, so let's try this again. Let's do file plot. Hey, Darren. Yeah, I think the number one thing you got to do with KiCad is you just got to sit down and do something. So that's one reason why, or one way I try to promote BitPreserve is a project where you can kind of learn how to draw, at least the schematic side is learn how to draw schematics, because redrawing an existing schematic is much, much easier to sort of focus on how to use KiCad versus trying to design the circuit while you learn how to use KiCad. You know, if you take I need to learn how to design this out of the equation, then you can focus on okay, how do I represent this in a schematic? All right, I replotted it just because we needed to make the mistake. Acrobat is still crashing. I can feel it. It's I love. Okay, so let me give me a second. Let me get a web browser, a suitable web browser. Let's try this one. And I got to go find my file now. Projects, bit preserve. Okay. Apple 2E, power supply unknown. So here's our PDF. I'm going to drop it into Chrome. And like what I had wanted to, all I was trying to point out is like things like the text fields are actually text. So I can copy them and then paste them, right? I mean, it's not, oh. I was looking at the YouTube preview. I was like, wait a minute. Anyway, so, I copied this text and you can paste it. Now, modern PDF readers will OCR stuff and do a pretty good job of it, but it's still nice that there is a full-on text version, and then the line or the drawn elements are vectors as well, so it'll scale and print very nicely. Now, some PDF readers, if they support JavaScript, I think is what we've determined, then the links are hyperlinked. However, and Acrobat is one of them. However, it keeps crashing on me, so I don't know I don't think I can show it. Anyway, if your PDF reader supports JavaScript, then you can click on elements and you can actually get all of the metadata for them. Which is also nice because it's in the PDF as well. So, well, except there, I think it's still binary. It still gets binaried. But anyway, Foxit Pro or Foxit Reader also supports this function. So anyway, that's why I do file plot instead of print to PDF, because you get a vector version of the schematic, which is much, much nicer to work with. Do I need a 2E power supply? Send me, if you have an extra power supply, Josh, send me a picture of the label, because I'm trying to figure out which supply design this is, and I'm not sure which I don't know which supplies I have. I have two 2E power supplies. And so if I don't have this design, I would like to see if I can find it. And if I do have this design, then I want to figure out what the other one is, because I think there's two vendors for power supplies. I think. I could be wrong. So anyway, okay. Okay. That is all good. Oh, you're moving again. I had a feeling I missed something you said. I'll pre-order. Oh, there's a new Atari 400 Mini? No way. Oh, and it's from Atari? Well, I guess that makes sense. Yeah, okay. Yeah, I don't know. I don't think I'm going to. It is super cute, though. The 2600 that they just started shipping in December or November really bothers me, because it doesn't do anything new. It's just running Stella, and it's not fully compatible with all cartridges. So they've kind of soured me on their mini systems. Oh God, it is? Oh God, I didn't, okay, hold on. Atari 400 Mini. God, I feel like such a heel. I'm going to look at the Verge article. Oh. Okay. Well, ignore what I just said. What's that? Retro Games does a really nice job with their computers. So, crap. So yeah, so I guess everyone's already probably asking, are they going to do a full size version? Yeah, actually, it is kind of interesting that Atari is promoting it. That was not. Yeah, I just assumed that they were doing it. Okay, well, shoot. Okay, so let's do this. I want to. So there, I'm not done yet because we have to fix something in the Apple II schematic, but I want to merge this in before I do that. So what we're going to do is we're going to stage all, and then we're going to go file, and we're going to say create it, version 1 PDF, excuse me. And then I'm going to tag this as 2E power supply 1 version 1. Come on. What is it mad about? Whatever. Okay. Let's commit that. Okie dokie. And then let's go over to here. GitHub com bald engineer bit preserve. Yeah, I mentioned that. Yeah, I'm actually really excited now because both the C64 Mini and the C64 were really well done machines. Like, yeah, they came out really nice, and so I am definitely interested in seeing one for another platform. Let's see. 2E power supply from Sam's computer repair book. All right, checking merge, confirm. I should have actually looked to see if I had any issues outstanding for it. I don't think I did. Yeah. Okay. So this is what so now what we want to do is now I want to come back to main and pull this down. What are you mad about? Well, I know why you're mad. Delete 2EPS1. Pull. No. Yep. Oh. I know why you're mad. I just wish you weren't. I'm going to delete this, and then I'm going to put this into Golden Delicious and reference documents. All right. Why are you still mad? What did I do? Oh man, why are you... What? What are you so mad about? How can those be untracked? What did I do? Didn't I merge these like just 10 seconds ago? Why does it think that they're untracked? Your local changes to the following files will be overwritten by a merge. Git ignore. That's normal. Okay, wait. Actually, is it... Can I just... yeah, I did merge the last ones because, or I'm pretty sure I did because the PDF is here. Right? Yeah. So because the PDF is here, I know that that last commit merged. Okay. What I'm really not sure why it's so mad. So I'm just going to do this. Since I barely understand how to use Git to begin with, I'm just going to fix this my way. I'm going to go grab this whole folder and put it somewhere else. And then try again. So it's mad about, okay, yeah, I'm at this point, I just don't even, Git ignored doesn't surprise me as much. Whatever. I was there. Yeah. I don't understand why it was mad. Like that. I must have, I messed up something. I don't know what. Well, yeah, I must have. You know, one thing I might have messed up. I might not have let Dropbox finish mucking with the files, and that might have confused Git. So maybe Git thought that the committed files were not actually committed. I don't know. Anyway, well, I wasn't going to branch this, but maybe I will now. Yeah, I don't. Yeah. Let's just do 2 plus report it. 2 plus fixes. Okay, so issue number 1. So actually, I think KiCad 8 is going to introduce Git support so that you can actually view Git issues in KiCad, which will be really nice. Or maybe a plugin is going to provide it. But okay, I don't want that one yet. This one. Let's go Apple. Apple and schematic error. Okay, so Q5 is reversed. So the first thing we're going to look at is in the two. So this person was looking at the Apple II version of the schematic, which we did not recreate or we did not fix the last couple of months. We were fixing the Apple II Plus version. So, which I'm embarrassed to not realize this, but there's no hardware difference, significant hardware difference between the 2 and 2 Plus. It's a different ROM. All right. So Q5, they're saying that this is backward. So now what we need is a reference, which we'll get out of Golden Delicious reference documents, and we'll do the 79 Apple II reference manual. and we're going to look for the schematics. Okay, so now I'm going to expertly identify view page display. Where's rotate view counterclockwise? We're going to expertly locate the reset circuit. Super quick. I'm going to see it in no time. You guys are going to be so amazed at how I find it immediately without any effort whatsoever. It's going to be like I knew where it was the whole time. You won't even believe how good I know this schematic that I've only looked at a handful of times now, because I really spent all my time on the 2E schematic that RJ redrew for me. I don't see reset in here or in here or in here. Here it is. So reset in this schematic is reset goes to the collector, and then the emitter goes to ground, and then the base is connected to a transistor. So we're going to look at this one, and he is absolutely correct. I'm sorry, the person is absolutely correct. That is backward. So, well, I highly doubt. Well, man, I would like to see a side by. I guess the first iteration. I would just imagine the first iteration would be side by side difference of commits. That would be kind of nice, I think. Yeah, that would be nice to see. So that way you could be like, all right, what did I change 3 weeks ago? Yeah, that would be kind of nice. Hey, Squire. Good to see you. So here's the problem. I don't want to make any changes to this Apple II schematic because I'm going to just trash it and replace it with the 2 Plus schematic. So darn, I was hoping it was in here. What I do want to, but I do want to fix this in the, we'll fix it in the 2 Plus. It's probably on this page, yeah. So we will fix this. Nice. All right, so status 2 Plus, 2 Plus, 2 Plus. I don't know why those got changed. What changed in these? All right. I don't want to. I almost want to ignore those, but I'm not going to. Flipped Q5 fixes. What number is this? 124. 124. Commit that. So fixed on the 2 Plus schematic. Pending fix on 2 schematic for future. Let me pick that up for future effort. How do I reference the commit? Can you reference it like pound something something something? I feel like that's not it. Do I just put the commit URL? Oh, they're saying the SHA hash. Okay. So then do I need the full hash? This is what happens when hardware guys play with software tools. Just the start of it? Okay. So I think that's what I did. So like if I just do that, I'm going to try this. I'll see what happens. Oh, look at that.
And there was much rejoicing. Yay!
That's not right. That's the wrong one. Oh. There we go. Okay. First try every time. All right, so we got that one. That'll close after we merge. Yeah. Later tonight, when I'm looking at a penny, I'll think of you. There's a preview button. Oh. Okay. All right. I'm going to leave that. Oh, well, never mind. Okay. So what's this other one? On the 2 schematic, IO strobe off of F3 should be marked as IO strobe goes to all slots, goes low, blah, blah, blah. Okay. Let's go see what that one looks like. And then let's see. So IO, where's the IO slots? Is it in here? I think they said F3, right? That's not what I wanted. IO strobe off of F3 should be marked as follows. Okay. Oh, okay. F3 is the designator. All right. Let's come back up here, and then let's do a Control F. F3 search. Pen names. Nope. Find. Really? Well, it's somewhere. Unless they meant something else. So... Oh. I wonder... Okay. I wonder. Maybe the two... No, they're the same board. Okay, so we're going to go back to the Apple II design. I'm going to search for F3. Yeah. it's not in here. It's probably in here. I wonder what they're talking about then. Oh, maybe they meant F13? Or that's a 138. Huh. IO strobe off of F3, which I'm not finding an F3, should be marked as that. Okay, so let's look for IO strobe and see what we find. Okay, so this is F12. I wonder if they just had the wrong designator. Okay, so let's backing up. Let's go back to the 2+ schematic. And then I'll just search for IO strobe again. Okay. Yeah, so I'm seeing this on F12. So I'm just going to assume for the moment that that was what they meant. And they think we should change this to IO strobe goes to all peripheral connectors, goes low when accessing address range. Oh. Okay. Yeah. That's an easy. Yep. Okay. All right. So now what we're going to do. So that's an easy fix. So now what I want to do is let's save this and then let's do plot to PDF. All right. Close all tabs. All right. Close that, close that, close that. And now we're going to do my favorite thing again. Okay, so then we're going to go to file status. We'll stage all. Fixed 125. F12 had the wrong address range. Range listed. And region or read it PDF. All right, so let's commit that. And now I know my little trick. I'm going to copy this part of the hash. And I'm just going to come back into the comment. And I'm going to say addressed in for the 2+ schematic. The 2 schematic will get fixed when it is in a future effort. The program I'm using for Git is SourceTree. So my friend, that's what she uses, and she more or less taught me how to use Git, at least enough to do enough damage that, or at least got me started with using Git, and it's the GUI tool that she used. I don't think I agree with the comment that you should learn how to use Git from the command line first, because there's too many times when I look at this and I think I don't know how I'd figure this out on the command line to restore something or go back to something or visualize something. That said, I do think you should learn basic Git commands, because sometimes it's just easier to do things on the command line. But yeah, I don't recommend or not recommend this program. It's just the one that I use. I used to use the GitHub desktop client, which was okay, but yeah. One thing I don't like about this program from my perspective, because I'm not super up to speed on how Git works, is that it is a little bit overwhelming sometimes. And so but that's not the fault of the software. That's a problem with me. Okay, so did I forget to do a merge last time? Is that what I screwed up? I think that's what I screwed up. No, that's not what I wanted to click on. That's such a bad picture. That's a picture I thought was really good until I made it into a thumbnail, and it's not. Fixes for 124 and 125 on 2+ schematic. Minor fixes. They were reported for the Apple II schematic, but since it needs to be reworked, I decided to fix these on the revised 2+ schematic. Sure, whatever. Giddy up? No, I have not tried that. Yeah. I mean and I think that's where it's funny when for me, this is totally a story nobody asked about, but what's interesting for me is to learn a tool like Git. I want to say that when I was in school, source control was not a super mature technology, and Git clearly didn't exist. And so I don't know when SVN came around, and when I got out of school, I ran into ClearCase in a couple of places. And so I know source control was around, but it wasn't as prevalent. So just maybe that's where I'm going. And so in the software classes that I took, which were very few, it was never mentioned or talked about. And so not being in a development role out of school, I never encountered Git until I started working on projects and stuff where I wanted to download something that was on GitHub. And so I've had to very much self-learn how to do things. And it's interesting to me because it's the same situation I see so many other people who ask me for help they get into, is that I see the mindset. Somebody, like when somebody comes to me with an electronics question, I understand the context of their situation much better now because I've been going through it with things like with Git. It's like, or another one is VS Code, and I mean coding in general, but VS Code. It's like none of these things are things that I was ever formally taught to use, and I never had a formal reason to use them. And so in a lot of cases, I'm like using a source tree. It's like, I just want to get this done. I don't care about all the steps that are required to make it happen. And it becomes a problem because those are important steps, like important learnings. So, yeah. Okay. Actually, Jack, CVS does sound familiar. I mean, I graduated school in 2000, so that's why I don't remember SVN like anyone ever talking about. And the thing is I worked in the computing center, and so I dealt with a lot of computer science people. And so like most of the people I worked with were computer science, or something related. And I just don't remember like CVS sounds, and it's not the drugstore. I remember the first time I heard of the drugstore, I was like, is that a computer store? But anyway, yeah, anyway, like I said, story nobody asked about. So, okay, cool. All right. We got the Apple IIe power supply done. We fixed two of the issues that somebody brought up on the 2 and 2 Plus. I need to think about how we're going to handle the 2 and 2 Plus, I'm not super worried about it right now, especially because they're so close to each other. I think an offline project I want to do is tear apart a power supply and see how it matches. And then in terms of bit preserve and streaming, one of the things I would like to start looking at is there are variations on the 2 and 2+ schematics, and I wonder if we should maybe consider documenting those somehow. Yeah, I'm not sure. I said that out loud, and now I'm like, I don't know what I want to do with those. So anyway, all right. Some of you have probably already seen it. There was a Workbench Wednesdays video a couple of weeks ago. I do have one coming up next week. So so go follow that stuff. And then I've got a project video that is queued up. I don't know when that's coming out, probably in the next couple of weeks. That's a RP2040. So it's supposed to be an RP2040 based project, and it took me like a week to get the boards working. And so the video became, here's how you troubleshoot boards. So custom RP2040 boards. And then I actually have an add ohms concept that I'm going. I keep coming up with ideas on how I want to start making. Anyway, I'm not going to bother. I'll just keep an eye out. As always, there's also the Discord if you want to stay in touch there. So okay, I'm going to take off. Everyone have a good one. Please try and find time to work on something that you enjoy doing. And thank you for hanging out while I did something that I enjoy doing, which is working on schematics in KiCad. All right. Catch you guys later.